California's snow was supposed to be at its deepest on April 1st. It hit its deepest on February 24th instead, 5 weeks early. And on the day it peaked, it had only reached 73% of normal. Everything after that went downhill. By the morning of April 1st, when state workers hiked into a meadow at Phillips Station, near Lake Tahoe, to take the most important water measurement of the year, there was nothing left to measure. No snow on the poles, no water in the tools. Just bare grass and a few thin patches the sensors could not pick up. The measurement was 0. It had come off the mountain fast. Across the state, the number came in at 18% of normal. The second lowest April snow level since California started keeping a steady statewide record in 1950. Only 2015 was worse. In the northern Sierra Nevada, where the state keeps its biggest lakes, the snow was sitting at 6%. And here is the part that does not fit the story you would expect. This was not a dry winter. California got close to normal rain and snow across much of the state this year. The water fell. It just did not fall as snow. And when it did fall as snow, it did not stay. That single sentence is the engine of the whole story. The water came. It came in a form California could not store. This story does not start with the April count. It starts with what the Sierra Nevada snow really is, because most people picture it wrong. When Californians talk about their water supply, they picture lakes. Concrete dams, blue water behind them, Lake Shasta and Lake Oroville. Those matter. But the biggest store of water in California is not made of concrete. It is made of snow. Every winter, storms come in off the Pacific and drop snow across the Sierra Nevada, a 400-mile wall of mountains running down the eastern edge of the state. That snow does not run off. It stacks. It packs down through the cold months into a thick, frozen layer, sometimes more than 10 feet deep high up in a good year. Water scientists have a name for it. They call it California's frozen lake. The way they track it is its own quiet piece of work. Some of it is done by hand, the way it has been done for almost 100 years. A worker pushes a hollow metal tube down through the snow, pulls out a core, and weighs it. The weight tells them the water inside, the number that really matters. The depth is not the point. 100 inches of dry powder and 40 inches of heavy spring snow can hold the same water. Along with the hand counts, the state runs a network of snow pillows, sensors that sit on the ground and weigh the snow stacked on top of them as it happens. It was those pillows, not a person with a tube, that tracked the snow vanishing day by day through March. In a normal year, that frozen lake gives about 30% of all the water California uses. 1 out of every 3 gallons. The water a farmer in the Central Valley puts on a field in July. The water that comes out of a tap in Los Angeles in August. A lot of it spent the winter as snow on a mountain. Here's why snow matters and rain does not do the same job. Picture 2 coolers on a hot afternoon. Pour a glass of water into the first one and it is gone in seconds, drained straight through. Drop a block of ice into the second one and it lets that same water out slowly for hours, long after the heat arrives. The Sierra snow is the block of ice. It is built to melt slowly, draining down into rivers and streams from April through July, right when California is hot and dry and needs the water most. Rain is the glass of water. It comes down, it runs off, and within days it is in the ocean. In 2026, California got the glass of water. It did not get the block of ice. The story of how the frozen lake failed is worth walking through, because it did not happen in April. It happened in February and March, while most of the state was not looking. December 2025, the first snow count of the season. The snow sits at 71% of normal. Below normal, but not scary. December is early. There was still time, and one strong run of storms in January or February can build a low snow level back up fast. February 2026, a run of storms moves through. Some of it falls as snow, but one of those storms is warm and wet. A long river of moisture in the sky that arrives at the wrong temperature and dumps rain on the high country instead of snow. Rain falling on snow does not add to the snow. It does the opposite. The rain carries heat into the snow and pulls the melt forward. This is the quiet trick underneath the whole season. Whether a storm builds the frozen lake or drains, it comes down to a few degrees of air temperature. The same storm, the same amount of water in the sky, lands as money in the bank if it is cold, and a withdrawal if it is warm. In a colder time, the High Sierra was reliably cold enough that this was not a coin flip. It snowed up there, and the snow stayed. In 2026, several of the storms that should have added snow arrived a few degrees too warm and came down as rain. The water was never missing, the cold was. February 24th. The statewide snow quietly hits its deepest point for the whole year, 73% of normal. In a normal year, that peak does not come until the first week of April. This year, it came 5 weeks early, and it came in below 3/4 of normal. That was as good as 2026 was ever going to get. The clock was already running. The state just could not hear it yet. Then March arrived, and March is where this becomes a different kind of story. In March 2026, a dome of heat settled over the western United States and did not move. Temperatures across the West ran as much as 30 degrees above normal. It became the hottest March in the recorded history of the country. It earned a name, the Snow-Eater Heatwave. In the Sierra Nevada, the snow began melting at a rate of about 1% of its total amount every single day. Snow cover across the range, the share of ground actually covered in white, dropped from 52% on March 1st to 21% by March 24th, 3 weeks. More than half the snow cover gone, and it was melting even at the highest places, the spots that are supposed to be cold enough to hold snow no matter what is happening lower down. Most people never heard about the part that came next. As the melt sped up, the state did something it does not normally do. It ran about 100 extra snow counts across 18 separate watersheds and flew planes over the mountains to scan the snow from above. That was not done for show. It was done because the snow was disappearing fast enough that the normal once-a-month count could no longer keep up with what was real. The map was changing faster than anyone could draw it. California's river basins had their driest March on record at the same time the heat was pulling the snow off the mountains. Dry air above, record heat all around, and a snowpack that was already only 3/4 of normal on its best day. By April 1st, the meadow at Phillips station was bare. Now pull back from that one meadow and look at where the missing water was supposed to go. The Sierra snow feeds 2 systems that keep California running. The lakes in the north, Lake Shasta and Lake Oroville, are the anchors. Lake Oroville is the heart of the State Water Project, the network of canals and pumps that moves water south to about 27 million Californians and around 750,000 acres of farmland. Shasta, the biggest lake in the state, anchors the federal Central Valley Project that waters a large share of the nation's crops. Both systems were built around a simple idea. The mountains hold the snow through winter, the snow melts on a schedule in spring, and the lakes catch the runoff and dole it out through the dry season. The snow was never just water, it was timing. It was the part of the system that decided when the water showed up. In 2026, the timing broke. The people whose job is to measure this stopped using careful language about it. The way they described the season was that California skipped spring entirely and dropped straight into a summer heat wave, that what should have been a slow snowmelt happened all at once, weeks early. The thing that really shook them was not the low number on its own. It was the gap between how much rain and snow fell and how little snow stayed. The state got close to normal rain and snow in many areas. Much of it simply fell as rain instead of snow, and that makes guessing the runoff far harder than usual. The blunt take from the water science world was that this one year is as clear a sign of the pull of climate change as anything anyone has seen, and that climate change is now changing California's water system fast and hard. The results of an early melt move outward in stages, and each stage is bigger than the one before it. First, the rivers. When snow melts in 3 weeks, instead of 3 months, the water does not arrive gently, it arrives all at once. Streams and rivers across the Sierra ran high, fast, and cold in March, weeks before anyone expected them to. That puts anyone near the water at real risk. And it is also a missed chance because a lake can only catch runoff so fast before it has to let the rest pass through. And an early melt means the high country dries out early, which stretches the fire season open at both ends. Second, the lakes. And here is the one piece of good news in this story. California's lakes are actually in decent shape right now. Shasta and Oroville came into April above their normal levels because the 3 winters before this one brought enough snow and rain to fill the backup supply back up. The state is not facing water shortages this summer. That cushion is real, and it was built by 2023, 2024, and 2025. Third, the next year. The plain version is this. Because of the last 3 good winters, the places that depend on this water are fine for this summer. After that, it is wait and see. The backup supply was built by 3 good winters. A second dry winter in a row would start drawing that backup down with nothing filling it back up. The cushion is real, but a cushion only works once. Fourth, the farms. The April 1st snow number is what the state uses to guess how much runoff will reach the lakes, and that guess feeds straight into how much water the State Water Project promises to cities and growers. A snow level at 18%, with a northern Sierra at 6%, means a thin runoff guess, which means tighter shares for the Central Valley farms that put food on tables far outside California. Fifth, the power. The same lakes that store California's water also make its electricity. Water power needs water high in the system to drop through the turbines, and it needs that water to be let out across the long, dry months when the need for air conditioning peaks. An early melt scrambles both halves of that. Water that arrives in a March rush, before the lakes can hold it, is water that cannot be spent slowly through July and August. In a thin snow year, water power output sags right when the grid is leaning on it hardest, and the gap gets filled by other, more costly sources. Sixth, the rest of the West. This was not only a California problem. On April 1st, 2026, 8 other western states, Arizona, Colorado, Idaho, Nevada, New Mexico, Oregon, Utah, and Wyoming, all set brand new record-low snow readings, the lowest since steady tracking began in the 1980s. California's second lowest reading was, in a strange way, one of the better outcomes in the region. The same dome of heat that bared the Sierra also sat on the Rocky Mountains, which feed the Colorado River, the supply for another 40 million people. If you are finding this useful, subscribe. We cover water systems, drought, and earth science events every week, with the full picture you need to actually follow what is going on. By April 2026, the clear thing to compare it to was a year California water managers already knew well: 2015. In 2015, at the bottom of a drought that had run for years, the snow reading came in at just 5% of normal. State workers went out to that same meadow at Phillips station and found no snow at all. The governor stood on the bare grass where the snow should have been and announced the first forced statewide water limits in California's history. 2015 is still the record. It is the worst April snow level the state has ever measured. 2026 is now second, and the difference between the 2 years is the part worth sitting with. There is one small, almost silly detail in why 2026 ranked second instead of first. 2015 holds the record because workers found no snow at all at Phillips Station. In 2026, they also found no snow they could measure, but there were a few thin patches still showing on the ground, too thin for the tools to count, but technically there. That trace of snow you could still see is the whole gap between the worst April on record and the second worst. Now, think about that for a second. 2015 was the bottom of a long, harsh drought that had run for years. It took years of building dryness to make a number that low. 2026 made the second worst number on record after a winter with close to normal rain and snow. It did not take years of drought. It took one hot March. That is the thing worth pointing at. Not the single number, but how easily the system made it. The pattern underneath is simple. As average temperatures rise, two things happen to a snowpack. More of the winter's rain and snow falls as rain instead of snow, even up high. And whatever snow does build up melts earlier and faster, before the lakes are set up to catch and hold it. The snow line, the height above which the sky drops snow instead of rain, creeps up the mountain. Every foot it climbs takes ground out of the frozen lake and turns it into ground that just sheds rain. Snow that hits its deepest point on February 24th instead of April 1st is not a weather story. It is a calendar quietly moving. And every week, the peak slides earlier, the gap grows between when the water shows up and when California actually needs it. That shift seems small when the season started. A below-normal December, a warm February storm, it was not small. So a stack of questions hangs over the Sierra tonight. If the second worst snow level in the modern record can come out of a close to normal year, what happens in a year that actually is dry? How many good winters does it take to fill the backup supply? And how many bad ones to drain it? If the peak keeps sliding earlier into February, at what point does April stop meaning anything at all? And how do you run a water system built entirely on the idea of a slow spring melt in a climate that no longer reliably gives one? There are no clean answers to those yet. The honest reply to most of them is that the data does not say, not because no one is measuring, because the thing being measured is changing faster than the system was built to handle. The lesson water managers are taking from the year is that California's old water systems need to be rebuilt for a climate that brings fewer, warmer storms and shorter wet seasons. Where the whole game becomes catching water in the narrow window it is there. For now, what is left is the Meadow. Phillips Station sits quiet near Lake Tahoe, the same patch of ground California has walked out to every spring since 1950 to measure its frozen lake. The measuring poles are still there. The hollow metal tubes are stored away. The tools are still set and ready, waiting for next winter. The grass is bare. The snow that should be packed across it, several feet deep on the 1st of April, came and went in February. The lakes downstream are still full enough for this summer, holding water that 3 earlier winters put away. And on the mountains above the meadow, the snow that is supposed to be melting right now, slowly, on a schedule, into the dry months ahead, is already gone. It left in March. The rivers are already running, and California is heading into summer with its biggest store of water, the frozen one, empty months ahead of time.